So this is experiment number 4, designing multiplexer and demultiplexer encoder and decoder circuits. In this experiment, students will learn how to design and implement multiplexers and demultiplexers of different sizes using basic logic gates. They will also learn how to construct bigger multiplexer using smaller multiplexers. Students will also construct encoder and decoder circuits. Encoder and decoder circuits are very useful in information transmission, conversion, compression, and maintaining the secrets of any information. This is the theory, part 1. In part 1, we will implement multiplexer and demultiplexer. A multiplexer or MUX is a device that selects one of several inputs and forwards the selected input into a single line. A multiplexer of 2n inputs, 2 to the power n inputs has n selection line. So for example, we have 2 n equal to 2, that means 4 inputs. So for 4 inputs multiplexer, you will have 2 selection line. 2 to the 3 equal to 8. For 8 input multiplexer, you will have 3 selection line, which are used to select which input has to be sent to the output. A multiplexer is also called a data selector. A demultiplexer or DEMUX is a device taking a single input and selecting one of many data output lines which is connected to the single input. So actually demultiplexer is the opposite of multiplexer and multiplexer is the opposite of demultiplexer. Okay. So let's see the details of multiplexer. In computer system, it is often necessary to choose data from exactly one of a number of possible sources. Suppose that there are 4 sources of data provided as input signal D0, D1, D2 and D3. So these are the 4 different types of input D0, D1, D2 and D3. The values of these signals change in time, perhaps at regular intervals. We want to design a circuit that produces an output that has the same value as either D0, D1 or D2 or D3, dependent on the values of 2 selection pin S1 and S0. So this 2 selection pin over here, because there are 4 inputs, and for 4 input there are 2 selection pin because 2 to the power 2 is 4. Okay, so by using this selection pin, we will decide which input will be allowed to go at the output. Okay, look at over here. Here the number of selection pin is 2. So 4 combinations are possible using this 2 selection pin S0 and S1. Such as S1, S0, they can be, look at over here, they can be 0, 0, 0, 1, 1, 0 and 1, 1. Okay, for each combination, for example, for the combination 0, 0, we allow D0 to go out at the output line. If your input combination is 0, 1, we'll allow D1 to go to the output line. If your input combination is 1, 0, we will allow the signal D3, D0, D1, D2. This is at D2, not D2. So we will allow the signal D2 to go at the output line. If your combination is 1, 1, then we will allow the signal D3 to go to the output line. Okay. It is important to know that there is a relationship between the number of input and the number of selection pin. If the number of selection pin of the multiplexer is n, the maximum 2 to the n inputs are possible for that multiplexer. And the multiplexer will be called as 2 to the n to 1 line MUX. The MUX are also going to design. The MUX we are going to design is a 4 to 1 multiplexer. That means there are 4 input and 1 output line. There could also be 2 to 1 multiplexer, 8 to 1 multiplexer, 16 to 1 multiplexer, etc. depending on your need. For our design, there are 4 inputs and 2 selection pin. So actually, we have 6 input. 4 input of the data and 2 is the selection pin. Now, if we draw the truth table for 4 prefill inputs, there will be 64 input combination. But fortunately, we can do it in a more convenient way as given below. Look at over here. This is the table. Depending on the selection pin, if they are 0, 0, will allow D0 to go at the output. For 0, 1, will allow D1 to go out the output. For 1, 0, D2 will be allowed to go at the output. For 1, 1, D3 will be allowed to go to the output. Okay. So from the above truth table, we can write the function as follows, like this. Okay. D0, S1 bar, S0 bar. Okay. Then D1, S1 bar, S0. Okay. And third term, I think, is D2, S1, S0 bar. Okay. And finally, D3, S1, S0. So if you just implement it over here, look at over here. Very simple circuit. This is the two selection pin, S0, S1. Okay, this is the line with inverter and this non-inverted line. And what we use? We use 1, 2, 3, 4. Just implement this logic equation, okay? 4 and 8. And this is the input to the AND gate. So what happens? When S0, S1, they are 0, 0, D0 will be allowed to go to the output. When they are S0, S1, that means when they are 0, 1. Okay, S0 is 1, 0, 1, then D1 will be allowed to go. Because look at over here. When all the input combination of this AND gate, like whatever S0 or S1, they are high, only then whatever is the D, that will be allowed to go to the output. Okay, so there are 3 inputs to each AND gate. The selection input must be high to allow the data to go to the output. So look at over here, depending on your design, okay, the selection line to the AND gate will be high, so that whatever is at the data input, that will come to the output. So very simple circuit. So let me see the simulation of a 4-to-1 multiplexer. Okay, I have already given the circuit over here. I think if you just scroll down, 4-to-1 multiplexer. Look at over here. 4 input, 4 AND gate. Okay, and 2 selection pin, S0, S1. S0, S1, 2 selection pin, and this is the 4 data input, I0, I1, I2, and I2. Okay, and let's do the simulation. Let's find out, okay, how it is working. So let's go to the Multisim Live.
This simulation is online multisim simulations.
Yes, online Multisim Live. We already know how to work with the Multisim Live from one other labs. I have already done it, right? Already you know how to work with the
Yes, sir.
Multisim Live. So go to the Multisim
Yes.
Live. I have already tested all the circuit for you. Let me just open the circuit. 4-to-1 multiplexer. 4-to-1 multiplexer. So let's open the circuit.
Hello, sir.
Yes.
সার্কিট গুলো একটু শেয়ার করা যাবে আমাদের সাথে?
Yes, I have already shared on the circuit. Look at the document. This is the document DSL lab for Multisim Live circuits. I have uploaded this document in your post section. Just download the document. I have shared all the circuits with you. Just look at the circuit and implement the circuit on Multisim Live. I am just giving you some demo of the circuit 4-to-1 multiplexer. Okay, look at over here. two selection pin S0 and S1 and 4 input I0, I1, I2 and I3. Depending on the selection pin, the input will be allowed to come to the output. So let's run the simulation. I am just clicking the run simulation button on the top left corner. Yes, now look at over here. Selection pin, both S0 and S1, they are 0, 0. So whatever data at the line I0, that will come to the output. It will ignore all the data. Okay, look at over here. The data at the line I0 is high, so the light is on. Let me just data at line I0 is off, 0, 0 is come to the output. So for this input sequence S0 and S1 0, 0, it is the circuit is allowing the input I0 to come to the output. If I0 is 1, 1 is coming to the output. If I0 is 0, 0 is coming to the output. Now we'll allow the input I1 to go to the output. So how we can do it? We use the selection pin 0, 1. Okay, 0, 1. Okay, 0, 1. It will allow I1 to come to the output. I think 0, 1, I think these sequences are just reversed over here. This S0, that means it is LSB, this MSB. So in this case, this should be the 1 and this should be the 0. Because S0 is the LSB, S1 is the MSB. So in that case, it will allow this I1 to come to the output. Look at over here. Whatever is the value of I1, if it is high, light is on. If it is low, light is on. Okay. So again, we want to allow input I2 to come to the output. So we need to select the selection pin. A0 should be 0 and S1 should be high. Okay. Now look at over here. If I2 is 1, 1 is coming to the output. If I2 is 0, 0 will come to the output. Now we want to make the input I3 to come to the output. So how we can do it? We need to make the both selection pin high. S0 is high, S1 is high. In that case, whatever is in I3, that will come to the output. I3 is 0, 0 is come to the output. If I3 is 1 or high, high value will come to the output. That is black is on. So this is the multiplexer circuit. There can be many inputs, but you will allow only one input to go to the output depending on the selection pin. Okay. So this is the multiplexer, and the opposite of multiplexer is the demultiplexer. Just opposite. Okay. In demultiplexer, there will be only one input. Just opposite. Look at over here. This one input, only one input. Okay. And this one input will be allowed to go over one out of 4 output line. Just opposite. Okay. Let's see how it works. The multiplexer circuit. Go to the home. Okay. One to 4 demultiplexer. Just opposite. Okay. Of 4 to 1 multiplexer. So let's open the circuit. Okay, look at over here. This is the data. Only one input. This input or a single data item will be allowed to go over 1 out of 4 output lines, depending on the selection pin S0 and S1. Okay. So let's see. Both are 0. Let's run the simulation. On first time, what we want to do? We want to pass data at first line. So both should be 0, 0, right? Both selection pins should be 0, 0. Look at over here. The data is coming to the first output line. If it is high, high is coming to the output. If it is low, low is coming to the output. Okay. Next, we want to pass this data DG1 on the second output line, not first output line. In that case, we'll make this one 1, this one 0. Look at it. Data is coming to the second output line. Now we want to make, okay, this input should appear on the third output line, not second. In that case, this should be 0, this should be high, and data is coming to the third output line. Okay. Now we want to make that this data will appear on the fourth output line. So we'll make both high. Data has arrived on the fourth
So
output.
what could we say indicates a DG1?
Yes.
So DG1 টা স্যার আসলে কি
This is the data input. We have seen the
DG1 টা স্যার একবার হাই একবার লো করে
or low value. Any value can be whatever it is. That means it's telling any value it can be, but that value will be allowed to go through over 1 out of 4 output line depending on the selection pin. Okay. So whatever it can be 1, it can be 0, but whatever value it will appear 1 out of 4 output line depending on the selection pin. That's the demultiplexer. Just opposite of multiplexer. Opposite of multiplexer is demultiplexer. Okay. So let's go back to the lab sheet. I have given the circuit. Okay. If on the file you will find both circuit. For 1 to 4 demultiplexer circuit we have just seen. Okay. And 4 to 1 multiplexer circuit. So these two simulation already we have seen on Multisim Live. Now let's go back to the lab sheet. Okay. It is also possible to construct 4 to 1 multiplexer and 1 to 4 multiplexer using 2 to 1 multiplexer and 1 to 2 demultiplexer only. Figure 3 and 4 show the construction of 4 to 1 multiplexer using 2 to 1 multiplexers and 1 to 4 demultiplexers. Okay. Next is the encoder and decoder. An encoder is a device or a circuit that converts information from one format or code to another. Encoder and decoder are widely used in telecommunication. Okay. Let's say you want to send a secret message, okay, to your friend. You don't want to reveal the content of the message. So what you'll do? You'll encode your message. And at the receiving end, your friend will decode the message to find out what is the secret information that you have sent. Okay. So it is widely used in telecommunication system encoding and decoding. An encoder is a device or a circuit that converts information from one format or code to another. A decoder does the reverse operation of the encoder. It undoes the encoding so that the original information can be retrieved. Both the encoder and decoder are combinational circuits. Encoding and decoding are very widely used ideas. They have applications in electronic circuits, software programs, medical devices, telecommunication, and many others. In this experiment, a very basic 2 to 4 line decoder and a decimal to BCD encoder will be constructed. Okay, so let's see 2 to 4 line decoder. Okay, 2 to 4 line decoder. This is two line, two input. Okay, AB two input. Depending on the input, one out of four line will be activated. For example, if AB both are 0 0, this line D0 will be high. If they are 0 1, then D1 will be activated. If they are 1 0, D2 line will be activated. If they are 1 1, this D3 line will be activated. Okay, 1 2 to 4 line decoder, and this is the logic question on the truth table. Let me just show you the simulation. I have given more decoder and encoder together. Okay, look at this circuit is decoder in this circuit is decoder in one side, another side encoder. Okay, for decoder. So this is the circuit we are going to design. 2 to 4 decoder. So let's see. Let's go to the Multisim live. Let's go to the home. Okay, I need to test of the simulation first. So 2 to 4 decoder. 2 to 4 decoder. Look at over here. Let's open the circuit. So look at over here. Let's run the simulation. This is the two input A and B, and four output line D1, D2, D3, D4. So it is decoded. That means, let's say this is the secret code. AB is the secret code, and this circuit will decode it. That means we'll find out the hidden information. So we are sending the secret code at AB, and the circuit will decode that secret code and we will find out what is the information. Okay, let's see, run the simulation. Let's say here your secret code is 0 0. Okay, your secret code is 0 0. In that case, we select the first line here. That's the decoding. Okay, what is the meaning of your secret code? That means this is the meaning of your secret code. D1, line D1 is high, activated. Suppose you're sending you are sending 0 1. Okay, that means this is 1. You are sending 1 0 1. So second line will be activated. 1 0. Third line will be activated. 1 1. Fourth line will be activated. Okay, so this is the decoder. It is decoding the code. This is the code you are sending, and the circuit, this is the circuit. This is decoding the code to find out what is the secret information. Okay, so let's stop the simulation. Now let's go back to a lab sheet. There are some other extra circuit I have given to you. Let's say this is a decoder and encoder together. Okay, one side is decoder, other side, right side is the encoder. Okay, 2 to 4 decoder. Actually, this is 2 to 4 decoder one side. 2 to 4 decoder. Okay, so after that, I think let's check your lab sheet. What is next on the lab sheet? 2 to 4 line decoder. After this, we need to do a decimal to BCD encoder. A decimal to BCD encoder converts a decimal number into a binary coded decimal BCD. Okay, it is encode. That means it will convert this decimal number, whatever we give at the input, as a binary coded decimal number. Okay, so let's see how this encoder works. Decimal to BCD encoder. This is the circuit diagram, but let's go more closely with the simulation. Let's go to the home. Decimal to BCD encoder. I think this is the circuit that, yes, let's open the circuit. So look at over here. You are encoding the decimal number. Decimal to BCD encoder. Binary coded decimal. Okay. This is widely used in computer. Look at over here. This is a decimal number. 0 to 9. Okay. This is first number 0. Then second number up to 9. Okay. There are 10 switches. 0 to 9. Okay. They are the decimal number. Okay. 0 to 9. So they will be converted to binary coded decimal. So let's say run the simulation. Yes. Let's say we want to encode decimal 0. So press the switch. This is the decimal 0. I think decimal 0. No, I think this is open. So we need to make sure all other switches are open. Okay. Yes. Now look at over here. Only one switch is closed at a time. We want to encode 0 value. This is 0. Then 1, 2, 3, 4, 5, 7, 8, 9. Okay. 10 decimal digits, 0 to 9. First one is 0. Switch is closed and it will be inputted as low, 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 low. So for 0 bit. Okay. Now we want to encode 1. This switch is for 1. So let's open it and close it. Okay. Now look at over here. So 1 has been encoded in binary 0, 0, 0, 1. That is 1. Again, open the switch. Okay. And close all other switches. So 0, 1, 2. No, open, open, only this close that you want to encode. So this is 2. 0, 0, 1, 0. This is 2. This is the LSB, this is the MSB. Okay. Now we want to encode 3. So open other switch. 3. So look at over here. 0, 1, 2, 3. Okay. So what do we get? 0, 0, 1, 1. 0, 0, 1. So we get 3. Okay, now let's say want to get 4 at the output. Okay, this is 4. 0, 1, 0, 0. Similarly, you can test. Let's say this is 9. Okay, this is 9. So 1, 0, 0, 1. That is 9. So this circuit has encoded the decimal number. It is called binary coded decimal. So again, go back to the left sheet. Hopefully you have understood the operation, and the circuit diagram already given to you. Now, last concept over here we are going to see is the priority encoder. What is priority encoder? Let's say you are 4 friends, okay, and you want to consult with your teacher. But you can consult only one student at a time. So let's say uh, there are 4 students. So which one will get the chance first? Who will get the chance first? How we can decide? Okay, this student will get the chance first to get the service. So what concept we are going to employ over here? A concept called priority based. Suppose if you come early, you will have the chance first. But if you cannot make it early, then okay. So who will come early will get the chance first. Okay, that's the priority encoder. Let me explain then the circuit. I think I tested the simulation most likely, yes. You see, you tested the simulation before you can navigate. So go to my circuits. So priority encoder. See, 422 priority encoder. Priority encoder. A priority encoder usually have 2 output line active at the same time. Look at over here. Let me explain through the simulation. Okay. Let's say there are 4 students D0, D1, D2, D3. Okay. For example, student D3 has arrived first early, so he will get the highest priority. After D3, D2 has arrived. After D2, D1 has arrived, then D0. Okay. So according to arrival, D0 will have the highest priority, right? So let's see. So when a higher priority device make a request, at the same time, lower priority device cannot make the request. It's called priority encoder. The device that has highest priority gets the chance first. Okay, let's see through the simulation. First make all 0. Okay. All 0 means none of the device has requested the service. So this called there is no valid signal or interrupt signal. Through this gate, we find out whether there is a request by the input lines. If there is no request from the input line to use the system, then this valid signal will be low. That means there is no request pending. But for example, let's say D3 want to send information. Okay, let's say when D3 want to send information, he will be go high. You see, this is MSB. Okay, in this case, so MSB has highest priority and it is encoded. Okay, so it has the highest priority. Okay, so look at over here, two output line. Okay, that represent 0, 1, 2, 3. You see, if you look at the input combination, look at over here, 0, 0, 0, 1, 1, 0, 1. Okay, so for choice 0, 1, 2, 3. Look at the simulation. Okay, so this is the fourth output, D3, 0, 1, 2, 3. So in that case, look at over here. Both lines are active. So it has encoded, pattern encoder. It has encoded this input D3. This is 3. Okay, and it has encoded this signal D3 right to LED light. Okay, now when this D3 has been encoded, let's see whether other device can encode or not. D2, no use. D1, no use. D0, no use. So they cannot be encoded while higher device is getting encoded. So what has happened? D3 has been encoded 1, 1, and this third input, third output is showing that there's a valid request for encoder. Okay, there's a valid request from any input device. Let's say there's a request from device number 2. But since device 3 has the request and has the higher priority, so device 2 cannot get the chance. But what happens in case device 3 does not need the service? Now, so look at over here. 1, 0. This is 2. Okay, 1, 0. This is 2. Now, let's say we want to encode D1 and D2 has the higher priority. So in that case, we cannot send this output. What we need to do, we first need to check whether higher priority device needs the service or not. If the higher priority device needs the service, only then D1 can send the request for the service. 1, 0. This is 1. This is 0. 2. Okay. 1, 0, 2. Okay. 1. Okay. This is 1. 1, 0 is 1. Actually, this is 1, not 2. 2 has 1 as 2. This is 1. Okay. 1, 0. This is 1. So it has been encoded, and it is only possible. D1 can encode itself only possible if this D2 and D3 does not need the service. Only then D1 can be encoded to 1. Now we want to encode D0 as the lowest priority. In this case, we will check other devices should not be activated for service, or should not have the any request. Okay, so they are all 0. Only then this D0 can go down. Okay, so that means 0 0. Both output 0 0 means D0. Okay, and since there is a request from D0, the valid line is active. If there is no request from D0, it will go inactive. So this 4-to-2 pattern encoder, it ensures that higher priority device will get the chance first. Okay, higher priority device will get the chance first. That's the priority encoder. So in your lab sheet, you have another design. They have given the priority sequence 2130, and the truth table is very simple. Look at over here. This is 4 device A0, A1, A2, A3, and this is the output line, priority output, and interrupt. Yeah, let's valid request line. This is the request line. So what happens when okay, 2 has the higher priority. Look at over here. 2 has the higher priority. When 2 has a high priority and 2 need the service, all other devices become don't care because 2 has a high priority. 2 has the high priority. So if device 2 need the service, other device become don't care. And this is the output. Okay, 0 1. That is 2. 12. Okay. Now, second has priority is the 1. So 1 is the second has priority. So in this case, if A0 and A3 become don't care and A2 does not need the service, so it is 0, only then this A1 can be activated. Okay. So what's the logic question? This is 1. Okay. 1 0. This one. Now, third option. 3 has the third highest priority. So when 3 need the service, A3 need the service, make sure A1 and A2 they have high priority. They should be 0 or they should not have a request. Only then A0 become don't care and the request come to the output. Okay, request come to the output. One one. That's 3. Now for 0. So device 0 will have the service only if A1, A2 and A3 does not get the service because A0 has the lowest priority. When all of the devices will not need the service, A0 can send the request. And this is the output. Okay, it represents 0. Okay, this is 0. And with priority encoder always there will be a third line. Okay, make sure in the real world design always there will be a third line. That means interrupt request line, or it can be used to show whether there is request or not. Okay, look at over here. The simulation. The simulation there's a line called valid line. This line get activated if there is a request. Otherwise, it does not get activated. So this is the priority encoder. And with this, I think I want to stop my own lecture and allow you to use the floor to do your own lab. But before we start the lab, I think I will give you a short break. How long you want the break? How long
20
you want the?
minutes.
Yes,
So 20 minutes.
20 minutes. Okay, let's give you the break for 20 minutes. So before the break, we talked about the priority encoder. Priority encoder ensures that highest priority device get the service first. Okay, and when there's request from higher priority device, lower priority device become don't care. So finally, we get the equation of y0 and y1. Okay, and there will be one more output for priority encoder called valid. Okay, so it's just you can use another output called valid. That means whether there is a request or not. That means when there is a request from a device, then valid output, like for this first situation, valid output, because there is a request in each step, valid output will be high. And otherwise, if there is no request, that is all zero requests, there is no request, valid output will be low. Okay, so it indicates that the valid output indicates that whether there is a request for or not. If there is no request, so the valid signal is low. Otherwise, valid signal become high, as you see in the simulation. You see, this is the valid signal. Okay, so look at over here. Let me run the simulation. You see, all zero. That means there is no request. So valid signal is low. If there is a request, for example, from this device, valid signal is high. Okay, if there is any request, this signal will be high, and if there is no request, this valid signal will be low. So priority encoder ensures higher priority device get the service first. Okay, that's the priority encoder. So now I think it's the time for you to implement all the circuit in Multisim Live. And if I go to the lab sheet, after this, let me see. So this is the equation of y0, y1, and there is one more equation for valid. That means valid will be high if there is a request, valid will be low if there is no request. So what you need to do, connect the circuit acting to the figure. I think what you need to do, just I have uploaded this document. So in your case for online, what you need to do, construct the circuit acting to this circuit diagram on Multisim line. Okay, this is a combined circuit, encoder, decoder. Left side, this is encoder. Left side is decoder, right side is encoder. Decoder and encoder together, okay? This is 3 to 8 decoder. So I have given some more circuit for your information. You don't need to implement all the circuit, only the circuit that is in your lab sheet you need to implement. So try to implement the circuit on Multisim Live, as many circuits as you can till the time permits. Okay, it is not mandatory that you finish all the circuit within this time limit. As far as you can do it. Okay, so try to start your work, and when you are done, you can leave the lab. And if you find any difficulty, any problem, I am over here to assist you. So start your work. and from time to time give me some feedback so that I can feel that you are working, not sleeping. One interesting thing, okay. Have you done any CMOS implementation in any other course? Complementary MOSFET?
ULC theory
Okay, there's an implementation of 2 to 4 CMOS decoder. Look at over here. This is the CMOS implementation. Just for your information, I am just showing this one. This is CMOS implementation of your circuit 2 to 4 decoder. Two input or 2 to 4 decoder. And now it's CMOS implementation. Complementary MOSFET. Just for your information, okay? You don't need to do it. Just do the circuit that's mentioned in your lab sheet. So go ahead, and I am over here from time to time. Give me some feedback.